Good morning, students. Consider the algebra of limits. So it is four important theorems are there. Out of four theorems, one theorem will be definitely asked in your examination: addition, subtraction, multiplication, and division. Okay. Today we will see about addition and subtraction. First theorem. So that is prove that limit of f of x plus g of x as x tends to a equals to limit of f of x as x tends to a plus limit of g of x as x tends to a. By using the limits definition, so we are proving this result. First you have to consider limit of f of x as x tends to a equals to L. So we have to consider this part as a, f of x as a, and g of x, so that is m. Limit of f of x as x tends to a equals to L. According to the definition of the limit, we are writing this: for every f1 is greater than 0, there exists delta greater than 0 such that modulus of f of x minus L is less than epsilon by 2. For every 0 is less than mod of x minus a, which is less than delta 1. Call it as equation number 1. Here we are considering less than epsilon by 2. In definition of limit, we are considering as less than epsilon, because here we are considering two functions, f of x and g of x. If three functions are there, we have to consider it as epsilon by 3. Okay. Similarly, we have to consider this part as L and this part as m. So next, limit of g of x as x tends to a equals to m. According to that same part, according to definition of limit, we are considering this as m. There exists delta greater than 0 such that modulus of g of x minus m is less than epsilon by 2. For every g of 0 is less than mod of x minus a, which is less than delta 2. Call it as equation number 1 and equation number 2. So in the next step, we are combining these two equations as one equation by considering delta is equals to minimum value of delta 1 and delta 2. See here, modulus of f of x minus L is less than epsilon by 2, and modulus of g of x minus m is less than epsilon by 2 for every 0 is less than modulus of x minus of a, which is less than delta. Here we are combining delta 1 and delta 2 as delta value. So call it as equation number 3. So just consider this equation: modulus of f of x plus g of x minus of L plus m. Here addition is there, so we are considering as plus. That is modulus of f of x plus g of x minus of L plus m. So this equation only we are considering here. Okay. If it is addition, we have to consider it as plus. If it is subtraction, we have to consider it as minus, multiplication and division. Okay. So both LHS and RHS are both are same. There is no alter in these two equations. Here f of x, modulus of f of x minus L is minus L. Next, plus g of x minus plus. So it is minus m. Both are same. Okay. So here we are considering it is in modulus of a plus b form. If it is modulus of a plus b, this can be written as mod a plus mod b. Separately we have to writing this by putting the sign less than or equals to. Okay. So this theorem proof is that according to that, modulus of f of x minus of L is less than or equals to plus enter separate modulus g of x minus m. Modulus of f of x minus L can be considered as here it is epsilon by 2, and modulus of g of x minus m is less than epsilon by 2. Okay, less than epsilon by 2 plus epsilon by 2. If you take LCM, it is 2. 2 epsilon divided by 2, 2 to get cancel is epsilon. Okay, therefore modulus of f of x plus g of x minus of L plus M is less than epsilon. Okay, the condition is same. Here it is of the form modulus of f of x minus N is less than epsilon. See here, according to definition of limit, modulus of f of x minus L is less than epsilon. This can be written as, see here, this can be written as limit of f of x as x tends to a equals to L. Okay, this can be written in this form. In the similar way, it is of the form modulus of f of x less than epsilon. This can be written as limit of this f of x. Here two function is there, f of x plus g of x, as x tends to a is equals to, there it is L, here it is L plus M. Okay. L we are considering as limit of f of x as x tends to a, and M we are considering as limit of g of x as in the starting itself we are considering as limit of f of x as x tends to a equals to L, and limit of g of x as x tends to a equals to M. That only you have to substitute the value L and N. So we will get the result. Okay.